Hi, and welcome to the video for titration of an unknown acid lab explained. The purpose of this lab is to identify an unknown acid by performing two titrations. The first titration is the preliminary titration, and this serves two purposes. One, to know roughly where the equivalence point is, and that way when we do the second titration, known as the pH titration, we know when to control the volume of base we add, and that will become clear later. The other purpose is to calculate the mass of acid needed to use 20 milliliters of sodium hydroxide. Now that's important because if you were doing an actual experiment, it turns out that titrations work best when you're using about 20 milliliters or so, or at least 20 milliliters. In terms of the procedure, we're going to start by weighing out a gram of the acid, dissolving it in 50 milliliters of water. When we did the demo lab in last class, we used about 0.2. We're going to now use 0.5 to 1 milliliters of phenolphthalein because the color change is more vibrant and it's easier to see where your endpoint is. That's where the indicator changes color. After we have our acid solution, we perform our titration and we record the volume of NaOH we used. Once we have the volume of sodium hydroxide that we use, we can calculate the acid needed to use 20 milliliters of sodium hydroxide by setting up a proportion. Okay, so we're going to get started. Here we have our workbench. I already have out my Erlenmeyer flask, and to that I'm going to add 1 gram. Remember, when you want to add something, you just drag it over, and when you see the green plus sign, it means you're ready to add. So this is my unknown acid. I want about 1 gram in here, so I'm just going to type 1, and I have it on precise, so it will give me precisely 1 gram. And I'm going to click pour, and at the bottom it tells me 1 gram is transferred. That's how I know it's been transferred. All right, I can go ahead and close this now, and I can remove this because I don't need it anymore. All right, now we're going to add some distilled water. So again, I'm going to put it over on top, and then I'm going to click on the 50 for 50 milliliters, and this again on precise. I pour it in, and it tells me it's been transferred. All right, I'm going to go ahead and remove that. All right, the last thing I need to add to this is the phenolphthalein, so I'm going to add 1 milliliter. It tells me it's been transferred. I can now just make sure it's highlighted, remove that one. Okay, so we need to access now our burette. I go ahead and add a burette, and into the burette I'm going to go back to solutions. I'm going to find the 1 molar sodium hydroxide solution. I'm going to add that in there. The burette usually goes up to about 50 milliliters, so I want a little less than that, so I'm going to put in 45. So I'm going to go ahead and pour that. And I can't see it right now, so what the burette reading is, so let me just move this out of the way here. Okay, so I've already poured my sodium hydroxide in. I'm not adding anymore, but I want to see what my initial volume is because that's important. So when reading a burette, notice that the numbers increase as you go down. That means that the bottom of my meniscus, it kind of looks like it's exactly on the 7, but let's say it's a little bit below the 7. So if it's below the 7, it's between 7 and 7.1 because remember the numbers go up as you go down. So I could say this is 7.01. All right, once I have my initial burette reading, I'm going to go ahead and record that here. So for run 1 with phenolphthalein, I record that in here. All right, I can remove that now because I'm done with that. And we are ready to start our titration. So I want to pour sodium hydroxide into the flask. So I'm going to drag the burette on top. And it should look like this when you've done that properly. Now, in performing a pH, I don't want to, in performing the titration, I don't want to overshoot the endpoint, but I don't really know where that will be. However, I do have a little nifty trick I can use here, which is the pH. So as I'm adding base, I can see what the pH of the acid is going to be, and that will give me a sense if I'm near the endpoint. If I'm near the endpoint, because this is a weak acid and strong base, the pH near the endpoint should be above 7, slightly above 7. All right, so I'm going to start off with 1 milliliter portions. So I add 1 milliliter. Notice that in adding 1 milliliter, the pH is at 3.44. It was reading 14 before because it was reading from the burette with the sodium hydroxide. But now it's reading from the flask, and you can tell because it's highlighted. So 3.44. All right, so that's far away from 7, so I can add another. So far I've added 2 mLs, 3, it's at 4 now, 4, okay, still at 4, 5, okay, still kind of far. Oh, I added 6, and notice that the pH now is 11.71, so that's clearly in the basic range. The color looks a little dark to me, so I may have overshot it. What I'm going to do is I'm going to pause the video, and I'm going to set it up again. But now I know that what I'll need to do next time is I'll probably need to stop around 5 milliliters, because here I've added 6, so maybe I need to stop around 5 milliliters and start adding in smaller portions at that point. Okay, I'm going to pause the video now. When you come back, I'll have the new setup. So I have set up the acid solution again. I have my acid, 50 milliliters of water, and phenolphthalein in here. I'm ready to start my titration. I'm going to grab my burette and I'm going to drag it on top and start adding. Okay, so just to recap, last time I added 6 milliliters and that was too far. So what I'm going to do is I'm going to add 5 milliliters, and I can just go ahead and just add 5 milliliters in here. And then after that, I'm going to do it in smaller increments. Okay, so I'm going to go ahead and pour 5 milliliters. Oops, before I do that though, don't forget to record your initial reading. It's different now because I've already used some base. So now this looks like it's at 13.01. So I'm going to say it's 13.01. I'm going to go back into my data table and record that number here. I can cross out the old number and record the new number here. All right, cool, ready to start. So I'm going to pour 5 in. And the pH is 4.79. All right, so now what I want to do is I'm going to bring this down to 0.2 milliliters. And I'm going to monitor the pH. And when I think it's getting, if I think I see a slight pink, I'm going to record that value down before proceeding on. Okay, so we just added 1.2 milliliter portion. So now we're going to add another. Okay, it looks like it's slightly getting pink. So what I'm going to do is I'm going to turn that down to about 0.1. Okay. All right, I'm going to record this value as it stands. So right now it's between 18 and 19. It looks like it's slightly above the 18.5 line. So, and when we say above, it's between 18.5 and 18.4, for example. So I would say 18.49. 18.49. So I'll record that down, and I'm going to add another 0.1 milliliter drop. Okay, it still hasn't turned super pink. So now this one is 18.59. Okay, and then it gets this kind of pink, which actually isn't terrible. So somewhere between 18.59 and 18.69. So I'm going to go with 18.69 as where I'm going to stop. All right. So I'm going to go ahead and record that down here. And my initial, my initial was 13. Okay. And when I do when I subtract these two values, that gives me 5.69 as the volume of sodium hydroxide I've used. Perfect. All right. Last thing that I'm going to show you in this portion of the video is how we're going to use this information, the net volume of sodium hydroxide. So, as I said before, one of the purposes is to figure out how much of the acid we need to use 20 milliliters. For the 1 gram of the unknown acid, we use 5.69 milliliters. So I'm going to set up a proportion where I have 1 gram of acid over 5.69 milliliters. And I know I want 20 milliliters of sodium hydroxide. So notice they're both in the denominator, and I have an equal sign between these two fractions, and that's X grams of my unknown of sodium of the unknown acid. So I'm just going to perform a calculation here by cross multiplying. So I take 20 times it by 1, and then I have X times 5.69. When I do the math, I get that in order to use 20, X is equal to 3.5 grams. So now I know that for the next titration, I'm going to need to weigh out about 3.5 grams. So I'm going to stop this video, and then in the next video, I'll talk about the pH titration.